Good morning everyone. Today's my topic for seminar is N-MOS IC fabrication. So starting with the evolution of transistor from the small scale integration to very large scale integration. First of all, a transistor is a resistor or a semiconductor device which can amplify signal. एम्पलीफाई का मतलब होता है कि किसी सिग्नल की वोल्टेज या उसके करंट को इंक्रीज कर देना. सो अ ट्रांजिस्टर इज अ डिवाइस विच एम्पलीफाई सिग्नल as they are transferred from the input to the output terminals. The latest technology we are having are known as BJTs and MOSFETs, which are referred to as very large scale integration, and they consist of 20,000 gates to 1 lakh gates in a single transistor. Next, we are having the MOSFETs. The MOSFET is known as metal oxide semiconductor field effect transistor, which is an advanced version of an field effective transistor. The channel can contain electrons or holes. The channel which contains electrons are known as N-type MOSFET, and the channel which contains holes are called as P-type MOSFET. The next we are having the symbols, and this symbol of N-channel MOSFET. In N-channel MOSFET, the electrons flow from source to the gate side of the transistor, whereas in P-channel the electrons move from gate to source. Now next we are having the Moore's law, which was given in 1965 by Gordon Moore's. He predicted that the number of transistors refer to the number of gates used in the transistor will be doubled every 18 months, which means if we are having 10,000 gates today, after 18 months we will be having 20,000 gates in the same transistor. So next we are having the structure of the N-MOS enhancement mode transistors. So we have to deal with the fabrication of this N-MOS enhancement mode transistor, which consists of metal. So for the fabrication of N-MOS transistor, we have step 1. We will take a silicon wafer. A wafer is a slab of silicon. This is a silicon slab which is doped with p-type impurities, and after doping the silicon wafer, we provide it with a thick oxide layer of silicon dioxide, which is known as oxidation. The term oxidation simply means the process of converting the silicon to silicon dioxide by providing oxygen, and which is known as oxidation. So a small layer of silicon dioxide is formed over the slab of the silicon. this silicon dioxide layer is very thin, about 1 micrometer thick. The third step is to provide a photoresist material over the silicon dioxide layer. The silicon dioxide layer prevents the further oxidation of the slab or the semiconductor we are having. The photoresist do not allow the UV rays to pass through them. A photoresist is used to make sure that the UV rays or the UV light does not pass through it. So after applying photoresist to the limited areas, we will apply the UV rays so that the unwanted areas of silicon dioxide can be removed. स्टेप 3 का मतलब ये है कि जो हमारे पास ये स्लैब है सिलिकॉन डाइऑक्साइड का, उसके ऊपर हम फोटोरेजिस्ट मटेरियल जो होता है उसको लगा देंगे, और जहाँ जहाँ फोटोरेजिस्ट मटेरियल लगा होगा वहाँ पे जब यूवी रेस हम लोग गिराएंगे तो जहाँ पे नहीं होगा फोटोरेजिस्ट वहाँ का जो सिलिकॉन डाइऑक्साइड की लेयर है वो रिमूव हो जाएगी, और उस प्रोसेस को इचिंग बोलते हैं। तो इस स्टेप के बाद जब यूवी रेस पड़ जाएंगी तो जो हमारा स्लैब है वो कुछ ऐसा दिखने लगेगा स्टेप 5 में जो है। एंड आफ्टर स्टेप 5 we will add another layer of silicon dioxide which is approximately 1 to 2 micrometer thick, and over that we will use a thin oxide layer to form the gate. After that, a small layer of photoresist is used all over the slab, and the remaining photoresist is removed and thin layer of silicon dioxide is grown over the entire chip, and then polysilicon is deposited on the top of this from the gate structure. The polysilicon layer consists of heavily topped polysilicon deposited by chemical vapor deposition. तो स्टेप 6 जो है इसमें कुछ नहीं किया है, बस जब स्टेप 5 में एचिंग करने के बाद हमारे पास जो सिलिकॉन डाइऑक्साइड की लेयर बच गई थी उसके ऊपर एक और सिलिकॉन डाइऑक्साइड की लेयर हमने जनरेट कर दी, एंड उसके ऊपर एक पॉलीसिलिकॉन की लेयर डिपॉजिट कर दी जो हमारा गेट का काम करेगी। एंड for step 7 we make a N-type well inside the P-type substrate and over the gate surface so that a gate can be formed. And in step 8 the thick oxide is grown over all again and then masked with photoresist and etched to produce selected areas of the polysilicon gate and the drain and the source where connections are to be made. तो स्टेप 7 में होता है ऐसा है कि हम गेट को और बाकी टर्मिनल्स सोर्स और ड्रेन को जनरेट करने के लिए एक एन टाइप डिफ्यूज़न यूज़ करते हैं वेल बनाने के लिए, जो कि स्टेप 8 में जिसके ऊपर एक और पॉलीसिलिकॉन की लेयर हम लोग यूज़ करते हैं ताकि जो गेट टर्मिनल है वो कंप्लीट हो सके। एंड स्टेप 9 में हम उसके ऊपर मेटल की एक लेयर यूज़ करते हैं एंड फिर से वही फोटोरेजिस्ट यूज़ करके फोटोरेजिस्ट जहाँ जहाँ यूज़ करेंगे वहाँ का एरिया रह जाएगा एंड बाकी जगह यूवी रेज से रिमूव हो जाएंगी। एंड that is our step 9. The whole chip then has metal deposited over its surface to a thickness of 1 micrometer. This metal layer is then masked and etched to form the required interconnection pattern.